Okay. Thank you for coming. Thank you for hanging out for the week. We're going to hear and talk to you around all the buzzwords that get you to come, because that's what the slide is. We put all the buzzwords on there, and then we'll talk about, I don't know.
You forgot to put Angular up there.
Okay, yes. So I'm Steve Lasker. I work on the container registry at Microsoft. What do you do?
What do I do? My name's Shane Boyer. I'm a cloud developer advocate for Azure. So if you are having issues doing what you like to do on Azure, please find me, and we'll make sure that we can make you happy. Yeah. That's my job. I go back to the program team and say, we can't make you happy to do what you do on Azure. So my job is to do that.
He does it well. He's very persistent. Anyway,
I yell at Steve.
And many other people. So today we really wanted to talk. There's a bit of setup, and really it's a matter of how do we make all these systems reliable. So the first couple of minutes, about 10 minutes or so, will be a kind of an overview of just how to think about it, and then we're going to spend the majority of the time in demos, maybe fixing them some too. So the thing that I really kind of wanted to tease this out is kind of going back to some basics. I used to work on electronics and like walkie-talkies and broadcasting systems and all these things. And sometimes you could spend hours chasing something down, and it's literally power is the problem. Not that it's plugged in, because that's kind of obvious. That's the always frustrating phone call you get. It's like, is it plugged in? But is the power supply, have the right voltage? So there's some basics just to think about. And when I think about what makes systems reliable, it's around making the components and actually making the perception of reliability, because perception's reality, right? That's the main thing. So when you think about it, is power reliable, right? We have battery backups. We have all kinds of systems, redundant power supplies. And at the end of the day, that's pretty much out of your control other than plugging the thing in. So that's a key piece. Is the network 100% reliable? In the cloud, there's a lot of Ethernet and fiber connections that can go wrong, and backhoes that cause damage. Is the OS and framework reliable, right? We do fix things that sometimes break, or we fix something for a behavior that you were expecting. So that's unexpected things that come in. And of course, your code's reliable, so it's not you, it's us. It's always somebody else. But these are the things to think about around all of these, when you talk about reliability. And the trick question is, does it really need be reliable? And we're not talking about being sloppy, but it's about going that extra mile has very diminishing returns. Because most of the time, all the things you prepared for all the experience you had, you should absolutely do, and then something else is going to come and bite you. So I kind of like to just refer to this as failure is a real thing. Just accept your faults and the faults of others, and life will be good. Because if you just assume things will fail, you will be in much better shape. Right? These are just some random things. I like to do pictures, but then I get in trouble because who owns the picture. So it's really not a matter of avoiding the failure per se. It's making sure that when something goes wrong, you have some backup plan to be able to handle that contingency. And then what is the backup plan? So that's kind of, you want to really think about what are the alternative paths. And the path really depends. So that's what I kind of refer to as costs, right? How much code are you willing to write? We hopefully test it, and we actually maintain it, or somebody does. Hopefully, anyway. And how many redundant instances do you want to pay for, right? There are redundancies, you definitely want to have that, but how many regions? Where do you want to distribute to? How do you want to pay for them, right? These are all important questions. And it really also always goes back to what is it that you're trying to show? So I like to kind of think about these questions whenever I'm building various pieces. If the thing goes down for some amount of time, who's going to know and who cares? Would your customer be able to complete the important task? Right? That's the thing that you really kind of want to spend the extra time on, as opposed to the unimportant thing. And where is the single point of failure? Those are the things to kind of keep. And if you think about just plain old HTML, the most basic of all, what is the piece here that just doesn't matter? Right? Can you get the important thing done? Right? The picture is missing, but you can still get to the phone number. And I love when sites put the phone number as an image because they don't want to be scanned. That doesn't really help when I'm trying to look up your phone number on the internet because Yellow Pages and so forth don't really have I don't know, I think it just ads for something else now. But anyway, just think about those breakdowns. And in this case, the page didn't fail to load, just the image failed to load, and who cares? So, again, all that is fairly basic, right? Nothing's, just more of going back to basics and thinking about those. Now, here's the thing that gets interesting with the changes that have come in the last, couple of years. So microservices, right? It's really about these item-potent units of work. And we, instead of having these larger things that, one part that fails inside of it can, fail the whole thing, is can these things fail independently? Can they run independently? Can they be updated independently? But most importantly, we've been writing code for years for figuring out when our own code fails, or we're not able to make that connection. But we always kind of judge infrastructure as being 100% reliable. We always, back before I joined Microsoft, at a consulting company I worked with, when we were working with them, they would always ask us, hey, you're on this insider program. Can you tell us how long these VMs have been running without failure? Right? Have there had to be any reboots? It's all about the length of time of something running because we want to make the thing reliable. In the container space, when we start talking about Kubernetes, we don't really care how long they can run per se. The focus is more on how fast can the container start up. And is my code able to handle the fact that it was over here, now it's over here, and it bounces around? Because we want to be able to scale things up. We want to be able to move things over because this node might need to be updated. This area might have failed for some reason. Or I might have a job that I don't need to run every once in a while, so I don't want to pay for compute sitting there to run once a day, or once a week. Right? I want to run that task. It does it. It starts up super quick. It shuts down, and it's done. So we think about the orchestrators are now taking this thing as a primitive. So I have this animation. This part wasn't the part I broke. And I'm just building some images. And if you'll notice here, I didn't get into whether it's Kubernetes or Service Fabric or App Service or any of these. These are just the concept of container orchestration. So I build these images and I push them to a registry. I've highlighted some stuff around the digest. That'll come more important later. And then I have this thing where I tell the orchestrator, keep this thing running. This is what I want you to have so many copies of so many things. And that's its job, right? Desired state configuration, you can think about it. And you notice in that orchestrator, it's got that little database that it stores what it was requested to do. And then it goes off and says, okay, I'm going to run all of these things that you told me to. And if you notice, the registry is actually a critical, important part of your production deployment, right? It's different than when we think about with source code or even where the binaries might come from that I go to deploy, because in VM infrastructure, we run the VMs and they are assumed to be running. With containers, we assume they're going to fail, move, scale, or whatever. So now that release management part is done and these things are running. And it's Thursday night and you're all going to, where was it, Universal? Is it Universal tonight?
Yeah.
Okay, so you're all going to Universal and you're all going on the rides and drinking, because we can drink and ride, we just can't drink and drive. And through the night, there we go. The night.
Did you fail?
I think, oh no, there it is. It's just slower. Okay, so while you're on the ride, something happens, and we come back in because in the next morning, sitting at the breakfast area trying to have our talk, and we're not paged. Wow, there's dated. We're not texted, beepered, to tweeted, of what happened last night. You got to stop. You can't go to the session. You have to go to fix it. Because the orchestrators are designed to accept failure as a primitive. It went and said that node failed, don't know why, don't care. My job is to keep n numbers of these things running, and it automatically just deployed them to another node. So that's the interesting part around containers, is not just that I can build and run a container. The value of containers are not really envisioned until you can actually put it in with an orchestrator that picks up on that concept that's self-healing. So that's the bigger part that I wanted to kind of talk about. Okay, so now kind of the demos that we put together. So we were trying to think about, we wanted to talk about important and unimportant things and how you would program around those, because they are different, right? And we were trying to figure out what is a good example, and we wound up getting as far as a quote of the day, and we debated what the important thing was. Should it be, ordering a widget? Should it be, putting in a prescription? Whatever it might be. So we just decided to call it the important thing, because it makes it a lot easier. And right, kind of break it down to some basics.
The SQL part wasn't the important part.
No, actually, no, it's not in this case. It's pulling. I don't know where I open a connection or I'm pulling data back, but whatever. So we have 3 containers that we're running: the website, the quotes API, that's just pulling some quotes from a database, and the important thing that's actually intended to be talking to some important back-end system, AS400, another microservices, whatever it might be, that is getting shut down for backup on Friday nights for several hours, right? So that's the concept here. And the way we're stitching this all together is we have the demo 42 out on GitHub. So we keep all the source out there. We're using Azure Container Registry and Kubernetes, and we have SQL and this important system in the back. And we're going to use ACR tasks and Helm to do the deployments to Kubernetes, and we'll touch on that in the second half of it. And we automatically build and do some stuff there. So with that, as my mouse comes in, we'll transition over to some demos. And let's take a look here. So we got the website here. And we actually set this up purposely for you guys to go hit us, and we'll see how that works.
So don't go to that website right now. And don't click that button.
So we originally intended for you guys to submit quotes, and we were going to rotate through those. And then we thought through that.
Don't ever do that live.
So you can submit.
That is a read-only box.
So you can just submit them, and we have a couple that we've put in there. And we actually even put some tests on there that if it's not one of the ones that we like, you'll get a nice little message that says something like "nice try" or something. So that's the idea. And if you notice, as refreshing the page, you notice the quotes are rotating through.
Nobody's clicking that button.
Anyway, so that's our site. Now, of course, stuff happens, right? So let's come over here and play whack-a-mole.
That's a different demo.
Why is that a different demo?
We didn't make whack-a-mole.
Oh, actually, that is true. I actually been meaning to do this. Somebody's got some nice little container visualizations that you can kind of poke at them and kill them. So we'll come over here to Kubernetes, and I got the deployments here. And you can see here's my the set, and I've got the web, the quotes API, and the queue worker. And for some reason, I have 2 quotes running right now. So what I can do is, actually, we can just go let me scale this to 1 because it'll be easier to kill it. So let's give that a second, and it'll basically it's say, okay, you only want 1 running, and it'll go make that change. So it says desired state is 1, it's currently 2, and it should just shut that down pretty quickly. All right, there we go. So now, if I go to my pods, the pods are the instances of these things running. The deployments is what it's asked for. And where is my quotes? Hello world. I'm not seeing my quotes. Oh, there it is. Thank you. And we're going to just go pink. So now you're going to notice that pink. Did it fix it already?
I didn't fix anything.
Wait, I don't know what happened there. Okay, maybe I won't delete them. Let me just scale them down. I did this before, This is one of the ones I was messing with. So quotes API, yeah, it's already kind of.
So he's going to scale the actual worker process down to 0. So essentially it's gone. So we won't process any of those messages.
Oh, no, it's there. Okay. So now the quotes API is at 0. And you'll notice that now when I try to refresh the page, it's trying to make a real connection through the quotes API to the database. And poof. Now, how important is it to show quotes of the day on the site? And that's kind of the first part of this. So with that, Shane, fix this.
Please? No pressure. 7?
7, okay.
7.
7.
All right. So the architecture of this site, it is just a couple of ASP.NET Core 2.1 components. We've got a Razor Pages app, and we've got an ASP.NET web API that we're hitting. So if I'm looking at just the Razor Pages page right now, we've got this quote client that we're using, and what we're going to do on the onGet, this is our get random quote. Right? So this is what's actually going and trying to get that API. So what that's doing right now is it's using the quote client. We're already using an HTTP client to go and do that. And what you'll see here is in the constructor, we're just using a regular HTTP client, and we're newing that up, and we're going to get that. And just for demo purposes, we're timing out in 5 seconds. Who's currently just newing up an HTTP client and going and hitting their services and waiting for that to do its job? Somebody's already shaking their head no. So who's doing this every time?
Not anymore, he's not doing that.
It's okay, you can raise your hand if you're doing this. All right, so here we're calling the random quotes, we're doing a read async, and we're waiting for stuff to fail. In this particular sense, we're just throwing that exception and making that happen. Now, one way for us to fix this so that Steve in his front-end services is handling this, I could just do return new quote, and I don't know, what do we want to turn? We need an ID, and we need some text. Let's see, text equals, I don't know, we could say, everything is fine here. Now, how are you?
Anybody recognize that?
Who said that? Attribution.
That's all I got.
Oh, don't do that. Attribution. Why didn't we put author? That would have been a much better thing to put in there. Attribution equals, solo. Right, so that would have been a good thing to put in there, right? I could run that, and everything would be great. I could just play that. The problem is, although that would return everything is fine, and the page would render properly without an error, the challenge here is that we just keep getting freaking logs constantly and not really solve our problem. I've been in a lot of meetings, and probably you as well, where for days we're going, what happens if we can't hit our service? What happens if our external service, our external API that we're hitting that we might not own, what do we do in the instance that that thing is down, right? We've never had those discussions. Because it's always going to be available, even if it's a text file or if it's an FTP site or something like that. So how do we go ahead and handle that? One of the things that we can do, are you guys hitting that button? Yeah, woo, all right. So one of the things we can do is, in our startup class, here's where we're going and using the iQuote client just as a singleton. So every time we're getting a request, we're asking for the iQuote client. So I can actually go to our quote client, and instead of newing up a new client, I'm going to go ahead and add an HTTP client here. And instead of newing up one, we'll just say and add that. And then in our singleton here, instead of doing this, we're going to add HTTP client. Right. So what this does is we're using the new HTTP client factory. The reason this is a good thing is when you're doing it on the other side where we're just doing up a new one, although we're using orchestration, we're doing Kubernetes, and we might be doing load balancing and all that, even by doing that, we could still get socket exhaustion.
Did you commit that?
I will.
Okay.
But I'm not done yet.
Oh, really?
There's
more?
There's more.
It's supposed to be easy.
So the other thing I can do here as well is anybody using Poly? Okay. So there's a NuGet package, and we've created an interface for that for Poly to do retries. So one of the things I can actually add in here is a retry policy, and what this does is I can handle the transient errors and also look for a retry. So I can try and hit this. If it fails, I've set a retry for 3 times. So I'll actually try and hit that 3 times. And I'll have set up a retry policy. And the next thing I can do here is add the policy handler to do that. So I'll say an add retry policy. Add my policy handler. And hit retry here, not on caps. My retry policy. And now I can implement that on the quote client. So now I've typed that. The next thing we can also add in here is add a policy handler for a timeout. So now we can add, I'm actually going to add on all of my lines. I'm going to cheat a little bit. And I'll walk through these because Steve's getting impatient. So what we'll do here is we can add a timeout. So before we were adding a timeout on the within the client, now I can add a timeout here for 10 seconds. 10 seconds might be a long time to wait. This next line here is we're adding a retry for 2 seconds. And then finally, we're adding a circuit breaker for two times. Now, what a circuit breaker does is we're basically here creating a funnel. So we're going to do the retry. We're going to wait for 10 seconds. If that fails, then we'll do a retry again. And then we're going to try and say if that fails once, we'll go through that cycle again. If we fail twice, then we're actually going to wait 20 seconds before we go through that whole funnel again. So everybody out here who's failing and are hitting and hitting and hitting and hitting, basically you're doing no clicks. We're going to ignore all those clicks for 20 seconds until we go through again. Why this is important is if you're looking at big architectures where we have a lot of dependent services and we're trying to fire up a whole application maybe on the initial go or on maybe a future release where we're trying to fire up a new rollout, we have to wait for other services to fire up. I've actually worked at companies where we had to turn on the MSMQ service, and then the web service, and then the SQL server, and then these other 3 things. And if we didn't do them in a specific order, all bets were off. And we all had to start that whole process over again, and maybe roll back, and maybe wait till the next day. And there's hundreds of thousands of dollars on the phone at 3 o'clock in the morning, and some of us are falling asleep before we had to go through that process again.
So 20 seconds doesn't seem like that long anymore.
20 seconds is pretty good.
But it's kind of, I think about this as, and there were some airlines that went through this problem as well, is that as the systems were booting up, they were getting hammered so much they didn't get a chance to finish coming up. And I think of it as like the boxer that got knocked down.
We're the referee.
Give him a chance to get up. Give him a chance for a decent fight. Yeah. So in this case, we gave him 20 seconds instead of 10, or it's 2 rounds of, how many, I forgot what it was you had in there.
We had 2 times that person can get up. We'll get him up twice before we get down. Right. So yeah, it's not the UFC.
Not totally intense.
Yeah. So what I'm going to do, let me just double check and make sure we take out. Here, we'll just take out this 5 seconds here. So now what I'm doing is I'm injecting that client into our service here with all of that retry policy and that circuit breaker policy to enable this. So what I'm going to do is commit this. So we're going to kick off this build. Update for circuit breaker. All right, git push. Hopefully I'm in the right branch. Master seems right. It got rejected. What did I do? Oh, Steve.
What did I do? Did I mess with that one?
You did. You're updating charts. You're doing all kinds of things.
This is a Git test. How's your Git skills?
My Git skills are terrible.
Well, you're in a command line. What do you expect?
What? Oh, man. You got me all messed up here.
Sorry.
Man. All right, let's try this again. Whew. It's a good thing I didn't have to use like some visual thing. All right, so now I'm going to go over and I'm running a task here, so I'm actually watching the ACR task list, and you see at the very top, it's running demo 42 web on a Git commit. So it's kicked off that whole process of, it's got a webhook from GitHub that's kicked off our ACR build, that Azure Container Registry build. So now it's going to rebuild these containers and do all of the fun magic that Steve diagrammed out for us, where it's going to create those images, those brand new images, put them in ACR, and then Helm's going to pick those up and do the deployment for us. It's doing based on me fixing what he broke, but this could be the same process if I was doing a future build, a future version, same thing doing on Git commits.
I think it's all of our jobs to keep Shane busy.
This is when I usually pick up the phone or Skype him or Slack him or
slap him
or Instagram him or something like that. Say, Steve.
Okay, so what's happening here, and we'll go into the task stuff more in a moment, but basically we're just doing a build in the cloud. And then when the image is built, and we do a unit test in this as well, that actually it's not this, you're going for the unimportant thing, aren't you?
You want me to go to the unimportant thing?
The unimportant thing, it's the quotes.
This is the quote.
Oh, you just seeing
I
how
was
much
seeing how many people keep hitting it.
they keep on filling us up. All right.
You guys are not
This will be a
pressing
good
the button
scaling
fast
test.
enough.
So anyway, so it'll do the build and do the push, and what we're doing here is you switched over.
So I didn't switch over yet. So one thing I want to show is, although we fixed the actual pooling of hitting the API, and we're setting this up to be resilient, we could have done the same exact thing with actually posting, right? So as everybody is hitting that the post button, we could have just hit the API directly. What we're doing in this particular case is on the post, to make this resilient, we're talking about building resilient services, is we're actually popping all those into a queue instead of hitting the API directly. Most queues are 99%, we're like 3, 4 nines on the queues. We're actually plopping those into a queue and waiting for a queue worker. We actually have another project here where we're pulling those off the queue and processing them and then sticking those in the database, so we're not actually posting directly to the database. So here's an example where we're connecting to the storage account and then putting those in the actual queue, and this is Steve's magic. Hey, got it. We can put more data in there, right? So instead of hitting the API directly. But we could implement the same thing using Poly, using those HTTP client factories for that. The difference is, if you can't post it directly, what are you going to give back to the user? Sorry, everything is fine. It doesn't really do any good there.
Everything will be fine.
Everything's fine. Wait for the stormtroopers to come. So use that same type of process here to make sure that you're resilient from a posting perspective.
Okay, so let's switch this over.
Yep.
And so now with that backend queue down, when I refresh the page, and we could see that the build was done, right? We see the demo 42, that was succeeded based on a Git commit. So I could come over here, and now when I'm refreshing this page, we're seeing that actually it's coming back pretty quick. And that's because the circuit breaker is already tripped. So it's not even trying to make that request and doing the 5 or 10, 15-second timeout, I think is what we had on the page. So notice the page is refreshing quick. if I come over and we'll launch the Kube dashboard again, we'll get that quote API working again, we can see that it'll call into it. So we'll just get that running there. And we'll come over to the deployments and quote API. So notice we have 0 running, and we'll just simply bump this up to 1. So now that that's running, we'll see here, first it's going to take a moment because it's still in the circuit breaker and it's waiting a certain amount of time. It's kind of giving it a chance to start back up.
That's that 20 seconds where it was broken, it failed a couple of times, so we're going to wait for that 20 seconds, and then it'll actually try it again. I'm actually watching our timer.
See, I have no patience here whatsoever.
It's like my kids. Now it's starting to work. Now we're actually processing that stuff.
You just call me your kids?
I didn't say that.
Okay, so that's kind of the idea, right? So now it's working. Everything's good. And of course, I'm rotating through. So for each one of those calls, it's going through that second API. Obviously, not really needed to go through for a quote to go all of this, but that's kind of the point, is to show something more complex. And again, we'll kill it, and we'll see that go through that again. So we'll come over to here, scale.
Now you're actually going to scale the
quotes API.
The quotes API.
So now notice it's waiting. So it's now doing its normal HTTP timeout and saying, hey, I'm trying to make this request. I expect it to be there. So this is like the circuit breaker warming up. It's getting hot. It's getting hot. There's no quite flames yet. And it tripped. So notice now, as I hit refresh each time, it comes back very quick. So that's kind of the model that we want to be able to do. And the interesting thing on this one is we did it as the unimportant thing, because we don't really care what, it's nice that I get a nice quote. It's nice that I see an image, but if the image is broken, I can still make my request. If the quote, we stuck some simple quote in here for now, everything will be fine. Now, the more interesting one is the important part, right? If somebody's placing an order, if somebody's making a doctor's request, a 911 dispatch of something, if that person's on the phone getting they won lotto and they're really excited, we'll be positive here, and they need help. I don't know why they called 911 for lotto, but whatever.
They had a heart attack.
They had a heart. Yes, that's it. Thank you. Okay, great. And they need help really fast. Well, the person's typing in. They want to make sure they can at least capture that information, right? While the person's still on the phone. In this case, obviously, it's important. It goes all the way through the system, but we have to first capture that. So we want to be able to put it in something super durable that is a fast response, and then the backend can process it later. I need to come up with a better example. This isn't a good example. You're placing an order for a widget, your power supply that you left at home, that you want to make sure you get here for your conference. At the time you place the order, you don't need to know whether it actually got picked, packed, and shipped. Right? You know the order was captured, you know your credit card was captured, and they could fulfill the order later. So you want to get in and get out really quick. So that's the part we're doing here. And did you already show that part of it?
I did. That's the queues.
The queues. So what we want to be able to do there is obviously write it to a queue and get out fast. And then, of course, we have all these queue messages that are being processed. Oh, it's over here. So there's nothing there, nothing up our sleeves. And of course, now it's actually not that many. People aren't hitting us that hard.
They're paying attention to your talk.
So the joke here is we want, last time we did this, I was surprised at how many people had hit the site and submitted some quotes, and that thumb bar was getting increasingly smaller. And the idea is that we want to be able to process those. So we'll come over here, and in this case, we'll come to, I gotta go back to Kubernetes, that's right. Make sure it's still up. Okay.
So you'll see examples of this.
Did you go over the queue processor? Did you already review that?
Yeah. No, I didn't. But we could. I don't have it on my machine.
Oh, that's right.
Pull it up. So you always see examples of this in social applications and things like Netflix, where you got suggested friends to follow, and sometimes you see it, sometimes you won't. Sometimes you'll see next movies to watch. Sometimes you'll see them come up in your feed. Sometimes you won't. Typically, I see them on the TV apps. or it's an old list. And that's a situation where that API might not be available, connectivity might be down, and then maybe 3 seconds or the next time you go back to that list, it does come up. These are those types of situations where they're using this type of a pattern, where they're developing for that resiliency. Given how we've got it available in ASP.NET Core with just a few lines of code, I know that in the past for us to write that type of stuff, it is hundreds of lines of code in the past to do that, or you just say, I'm going to say everything's okay. We'll just try it next time. So now being able to just, with a NuGet package in Poly, or just inherently just being able to add a couple of lines and say, hey, in 10 seconds, try again, is a much easier pattern than before.
So here in the queue worker, it's just a job that runs, right? It's going to have some schedule to it, and it can, kick in. And we have the same kind of retry policies here, right? He set up the circuit breaker to trip, because we don't want this thing to arbitrarily fail. But if there's something wrong for some reason, in this case, we did really super simple. We're pulling it off the queue and sending it to the Vapor. But if I was pulling it off the queue and wanted to write it to that back-end system that may not be running all the time, this is where that buffer comes in. So reading off the queue is probably really reliable, but writing it may fail. So this is, again, where you'd want to have the circuit breaker kick in. And I think it was over here where he kicks in and pulls it off. So all this is on that sample you can take a look at. So now all I'll do is, let's go over here. So we still have a bunch of them there. And we'll just come over here.
1,600 messages in there.
Where's
Right there.
Oh, I have to page. That's okay, cool. Thank you. Queue worker. So we'll turn this up and we'll scale. And I think we need more than one. So we'll put.
I can fix this really quick.
How's that?
I just hit the clear queue.
Oh, that would be the best way to fix this. Is that fair?
One worker, one click, baby. Done, and we all go home.
Okay, so we can see it starting to come down. No, we see it kind of.
It's growing.
It's growing. All right, cool.
Did you scale the right worker?
I don't know. The queue worker, yes.
Still scaling.
Let's give it more.
You scale the scaler. I don't know. You're losing.
Am I not able to keep up?
You're losing.
We're at 12 of them running now. Wait, I got to come over here.
More power. I can still hit the button. You are losing bad.
Wow, I am losing bad. Well, I think we put a.
Somebody's got one of those gamer mouses out there. There's a game that my kids play, and they're like, I'm like, why are you clicking? They're like, I have to move my guy. 50?
Well, when Glenn wrote this, he put like a 1 second or 10-second sleep timer in here for each one it processes. So I guess we can you want to update that too?
Code. Change the.
No, just throw more compute at it. Why do I got to change the code?
I'm gonna go check my bill. now we're going down by.
I'm starting to catch up.
This is a 75-minute talk, Steve.
All right, we'll let that process.
I got some time.
Do you want? Actually, you can change that.
That's okay.
All right, so let's talk about when we were actually doing these builds. So we'll let that process through, and it's running the pick, pack, and ship and all the little automated forklifts and everything in the back.
Ooh, scroll bar is getting larger. All right, we're winning.
Oh, we're down. All right, we are winning. All right.
All right, go.
Okay, let's go back. I get very distracted by the squirrel. Okay, so we're back over here. So let's talk a little bit about those builds now. So there's a couple of things. As we're committing code, we obviously want to make sure that we can actually automatically build that, automatically deploy it, and you might want to test it as well. So we did write some unit tests in here, and there's a couple of things in here for good and great, and I think there's something here for something expected. And then the index, we actually do some work in here. This was part of the test, was realizing when we were first considering letting you guys type in, and we started going down this, we were going to do some poly check? Then the whole poly thing got even more confusing.
Actual words.
And we decided to back out. But anyway, the point is that we can actually make some tests using the unit testing framework and actually call our APIs. So that's what these classes do here. And if we look at our Docker file, Does this have the unit test in it? Web UI?
Not in this one.
Oh, no,
up
but
top.
here we go, run .NET test, okay. So we've broken this out, and if anybody's used the tooling that we have with Visual Studio, you might notice that we've broken this out into a couple of sections. And we did this intentionally because we wanted to make sure that you were set up for things like sticking in unit tests. So I'll do a real quick recap of what we have here. So we have from a base image, and I didn't grab the one directly that's out on Docker Hub because I wanted to show being able to do a base image update. So if I can't really go and change our public image just for a demo, that would not exactly be too cool. So here I assume the image that I'm basing on for the .NET SDK is in my same registry. So that's all that is. And I'm using a build arg that the registry is demo 42. So that's why that looks a little, when you can clone it and put it in your registry and your GitHub repo and in your container registry, you'll be able to name that yourself as well. So all we're doing is we're going to copy the tests, the test project in, and we'll copy the source in, and then we'll copy the web project. And we're doing this in this order around that layering capability of Docker files so that if only certain parts changed, we don't have to take the whole thing. We'll run .NET Restore, and then we'll copy in, because we're running .NET Restore on the NuGet, the NuGet package. And then we'll do the build. Now the idea here is that we're building the binaries, and all of the things that takes to build the binaries, like the SDK, I don't want that in my production image. Because remember I said we want containers to start up super quick. And the size will matter on how fast the image can get pulled to nodes also. So I really want to have a very optimized image that is just my binaries and just the runtime. I don't need the SDK and all the testing framework. So I'll say from build as test. So I'm taking those built binaries, and I'm going to run .NET test. And that'll actually run that other project. That's the unit testing that I can do here. And assuming that passes, and I don't have some bogus values in it, then it'll move on. So from build, right, I'm skipping the unit tests now, kind of going back up here to the build one, because it says as build. This is a multi-stage Docker file. As publish, I'll actually copy that into the optimized output into the release mode. So do the .NET publish. And then from base as final, so from the base, the runtime, notice it's the Linux runtime in this case, and I'm just calling it out specifically, and then I just call that out and I'm good to go. And I have this other environment variable is not as important. And then from base as final, so from this one, copy in the published output, and then I was goofing around with some environment variables. And then I set my entry point.
Now, Steve, you're doing a ton of stuff in this thing.
Yeah.
I bet they're assuming that this is like some 40 gig file you have going on.
The text file? It's right there. See,
The Docker file, Steve.
Yeah.
How big is this when you're all done?
Oh, and the images? When I'm done, actually, that's a good question. I haven't looked in a bit. Let's take a look.
Because you're doing tests, you're doing builds, you're doing multiple builds, and all that.
Do I have them here locally? No, I don't. All right, so the CLI, the Microsoft, that's the Azure CLI. Yeah, that's a good question. I'm actually not running them locally. It's an order of magnitude. I think the SDK is about a gig because we actually bring all of the packages into it. And there's a couple of different versions in there because we want to give you a good chance of being successful. And I think the final one is that 200 meg?
200 megs. So you're getting your builds, you're running your tests, you're doing all that. So the idea is behind the multi-stage builds, what we're doing is we're getting everything we need inside of this Docker image, and then we're throwing away everything we don't need, and that's that final image. And we're using Linux. If this was a Windows-based image, if you're doing full framework type builds, it's going to be a little larger because we're using Windows Server, Nano.
And it's compatible.
Nano
I mean,
server.
so we often get caught up in these questions of why is Windows Server so big compared to Linux? Well, Windows Server, we've been shipping a lot of stuff for you guys, and we didn't know which ones you didn't need. So Windows Server Core, that image, is all based on compatibility. We want to make sure that the things that you expect to run in it will run, and then Windows Server Nano is the smaller optimized image that's really meant for cloud workloads, and that's where you can use .NET Core and get it much smaller. Okay, so we've got our Docker build. The thing that we want to be able to do, though, is, and I showed you the unit tests, is we want to be able to automatically build this. And we've got a capability in ACR that we originally called ACR build for OS and framework patching. Because the interesting thing is, how do you patch a container? If I'm constantly killing nodes and scaling those up and constantly redeploying that image, every time I do a new image deployment, am I going to go run the OS update on it and patch that OS? Like, of course not. It'll be fun to watch all this compute spinning and watch the people that normally patch containers, patch VMs, keep on figuring out where all these things are running and try to keep up. But that's not really the goal. The way you patch containers is you actually rebuild the container itself. And with ACR tasks, we actually will monitor the base images, and when those base images update, we'll automatically build as well. So if we take a look, let's take a look at how we can do that. So let's take a look at in here in the README I talk about it. So a task is an automated build definition. And you can see these are the three that are really, well, this is also important. So I'm just going to create this task, and it's got a name of Demo42 Web. I reference, in this case, I'm referencing a multi-stage Docker file, and I'll show that in a second. But it could also reference just a Docker file. Sorry, a multi-step task. This could also reference just a Docker file. But you'll see why I want to do multiple steps here. I give it the context, which is GitHub, where we support GitLab as well, although we don't automatically hook up the webhooks. We'll fix that. And I just need a token. And the reason I need the token, first of all, it could be a private repo. But in this case, I actually want to set up a webhook so that when your git commits trigger, we want the task to fire as well. So that's all that is. And then the noise below is just around setting up a service principal to be able to do some Helm deploy and kube control. And we'll see that in a minute. So that's all I've got there. And if I look at the task, this is the ability to build. So first one is I'm building the image, and I'm giving it a tag. And I want the tag to be fully qualified, right? If you've all done Docker, if you do your Docker build and you just say hello world and you do a Docker push, where's it going to go? It's going to try to go to Docker Hub because Docker has defaulted the registry. If it doesn't specify a registry name, it assumes Docker Hub. So that's probably not going to go where you want. So what you want to be able to do is give it the fully qualified name. So the run.registry is just an object model that we have a bunch of variables in there, and that'll give you demo42.azurecr.io. So that's what that does. And then I'm just using a namespace, demo42 web. That's the image name. And then the tag, I want to uniquely tag the image. And tagging, I got a whole blog post in another demos that I do that talk about stable tags will create instability. So when you're doing a deployment, you always want it to be unique. And think about it as if I have a node that automatically scales and it pulls a newer version of the latest tag, then you have inconsistency across your nodes. So we always want a unique tag. So we give you the run ID.
Let me just switch over real quick to mine, and I'll show real quick. So this is a list of the tasks. So when we're doing the commits, when I do a git commit, I was fixing what Steve broke in the web. This is a list of the tasks. So I do a git commit of the code, and it's going to fire off that webhook to ACR, and it's going to look at the file that Steve was showing here, and the run ID that we're tagging our images is that left column there. So our actual Docker image is going to be named, demo web blah 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 colon the CA3F, and that's where that run ID is coming from.
And might ask, well, why don't I use a git commit ID?
Because they're this long.
Well, there's that too. I certainly don't want to type it, but I can use like the hash or something. Mm-hmm. The problem there is when you've got OS updates, you're going to have a new image that has the same code in it. And you want that to be unique as well. So that's why we're using, we provide run IDs. Of course, you can do other unique IDs, but I would not use a git commit as your unique ID going out. Okay, so we're going to build this. We're saying, in this case, the build actually does reference the Docker file. So there's a Docker file. And then I'm passing in a build arg. So this is how I make sure that when you guys clone it into your registry, it actually uses your ID. And then the context. Now here's where I could actually run another another one where I could actually build another test image and do functional testing. So it would actually make calls to it. And just for the sake of time, I'm not going to get into that. If all that passes, including my unit test, I'm going to push it to the registry. And then here's the part where we're doing the automatic deployment. So here, I'm just using, who's familiar with Helm charts or Helm? A few? Okay. How many of you guys know Kubernetes? And that's okay if you're just kind of getting here, that's right. So Kubernetes is a way to do, you're running all your containers at scale, and I want to be able to tell it to do a deployment. And if you're familiar with Docker Compose, how many people are familiar with Docker Compose? Okay. So Compose is a declarative way to say, I want to run these collection of containers, and they can talk to each other through the network DNS that it sets up. Helm is another way of doing that specifically to Kubernetes, because Compose was more targeted towards Docker Swarm. And if we look at our chart over here in our deploy project, here's my Helm charts, and I've got this Hello World one, and then I've got our important things. And here's the chart name, and then in the templates, you can see that this is where I'm stitching together the web, the queue worker, the storage account, setting the secrets for it. At the bottom, you can see, where's the secrets there? There's the quotes API. There we go. So here's where it's pulling out the information from the secrets. So this is kind of, think of it as an ARM template specific to Kubernetes. And that's kind of the model there. But when I've got the chart and I want to deploy it, I also want to have the chart saved in a place. And many people are saving their Helm charts in their source code, and that's perfectly fine. If you think about it, it's what do I do when I'm trying to deploy something that I don't have the source to? It might be WordPress. It might be an app that another team is trying to deploy that you've built, and they don't have access to the source. They're just trying to pull the images from the registry and deploy them. So what we've done is we've added Helm charts to the registry. Because if a Helm chart references images, then it seems logical to put the Helm chart with your images. So this week we've announced Helm chart repo support in the Azure Container Registry, and you'll be able to fetch charts from there. So what I'll do here is when I build this, I have a script that is basically going to, all that goo was we didn't finish getting the principal stuff, the authentication working. But when this is built, the main thing that I want to focus on here is it'll package up the chart and push it to the registry. So now, every time that chart changes, it'll be available for me. And when I'm doing my release over here in the web project, right, here's the web project. And we'll close up the test one. And you'll see that I've got a script here that also, like I said, we'll get rid of the login stuff soon. But what I'm doing here is I first tell the client. So Helm is a client-focused technology in Helm 2. So I need to tell my local store to go add this repo that I have up in the registry. So Helm repo add will actually bring the demo 42, in my case, repo locally. And then I can say Helm fetch. And Helm fetch is effectively Helm pull. We wanted to make it different. Does anybody sail or do any kind of boating? Okay. You notice how the languages is always completely different? I don't know why, but they wanted to use lots of different words for the same thing, like left and right. Why is that so difficult? But port and starboard. So anyway, Helm fetch is basically pull. And basically I'm giving it, pulling from demo 42 and important things, because that's what I pushed up. Now that I have the chart locally, I could do a Helm upgrade. This is telling Kubernetes upgrade the name of the instance that I'm running, demo 42, use the chart, important things, save the values that it already has, like don't purge your brain, just keep what you have, but overwrite this one variable that I've got in my chart. And it's the run ID, right? It's that unique tag that I've put for my image. So that's kind of the flow. I've got my chart that I don't have to rebuild often. I keep that up in the registry. As I'm doing a build, I'll come over to this task here. I'm going to build my image. I'm going to push the image because my unit test ran. And then I'm going to run, in this case, I'm going to run this deploy script. And if you notice really closely here, this is kind of cool. Command is basically Docker run. And I'm saying run this container. And you notice that that container even has a tag on it, so I can do individual versions. ACR task doesn't know anything about what's in the container. We're just going to run the container. So if you want to run something that's in Go, in Rust, in Java, Node, Python, whatever, we don't care. We're just going to run that container. And in this case, I've got a container that's got Helm and AZ-CLI in it, so I can run this script, and that was the script that we just saw. And then these are just environment variables that we currently have to pass in for the service principal. So if I run this, where was that? So every time one of these commits runs, you'll see that I can, like here, is it CA3F? We can say ACR, hold on, it's task logs. I forgot what it was already, CA3F. And as that thing runs, it'll just stream these logs, and we can see it did the build. Right, here's all our Docker build stuff. It did the unit test. Where's the unit test in here?
It's part of the build, Docker build.
Yeah, it's up in here. Web, yeah, here's the base. Pulling logs is always fun. Anyway, it's in here, it's in here.
Go down further.
Further?
Mm-hmm. Oh, it runs it fast. They're simple tests.
Yeah, wait, no, it's right up here though. Hold on. Run.NET build, web UI.
Right there.
Right there.
Build complete. There you go.
Oh, test, there we go.
Yeah.
And there's the test, yeah, here, sorry, total. So my past 6 8, I actually ran
tests.
Well, it was more than one. It was twice more than I started with. It tests the base image and it tests your APIs.
You're
that
not on
you
my
keep.
team.
All right. Anyway, so once that's done, what we'll see is that it also then went and did the Helm deploy. So this is where you'll see it's doing the Helm push. The Helm repo init. So it's creating the local one, and then it's grabbing, demo 42 has been added, and then it will do release demo 42 and happy helming. And it gives me, it always says happy helming.
Even when it breaks. Stay happy.
That's you should always be happy. And then when the task is done, this is the important part that we've built in here, is we track the base image dependencies. So here's the image that we built, Demo 42 Web. That's its unique ID. And you'll notice that its build time dependencies is the .NET SDK, and its runtime dependency, see it says runtime dependency, is the ASP.NET Core runtime. So now we're tracking that, so when that updates, it'll also trigger a rebuild. And then it automatically gets deployed. So let's actually do a quick example of that. That's Node. Excuse me, that's Node. And we'll go to, this is why I have a reference here. So we'll go to the ASP.NET Core runtime. We're going to go poke at the Docker file. And I think I did the back color as white. We'll change it to blue.
Buell?
Bueller. It's Bueller.
Bueller, all right.
I think it'll be a red car if I do that. I don't know if we'll go backwards, though.
Okay.
So you'll see there that now the ASP.NET Core runtime image is being rebuilt, and it'll push to my local registry. I don't know how long those were taking. And then once that's done, it should trigger a base image update for the other one. So we'll give that a second there to go. So with ACR Task, we also support Windows. You notice I've got the Windows build in here as well. This is the ones I was manually kicking off when Shane was starting the talk. Just because I needed something to do. What else did I want to cover there?
Now,
Wait, did we actually catch up? That's the important thing.
We did. I think somebody's running Selenium or something on us because they're running.
They're still, okay, they're coming as fast as they come in. We're getting rid of them now.
50 workers.
Oh, see, now everybody's poking at it again. Everybody was waiting for us.
Somebody set up like a DevOps job on it or something. All right, so I have a question.
Oh, there it is. Okay, hold on before you do that. So here, now the base image was a git commit. And notice that my 3 projects that all depend on that runtime are now updating. So now they triggered a rebuild. And as they're building, they're going to go through all the same things. They're going to run through all of our tests to make sure they're good. And no comment?
No comment.
No, he's already checked me out. He's already flipped the bid on my testing. But anyway, so once those are done, assuming the tests are good, it'll actually automatically do the.
It'll make my website blue.
I had Azure Blue, but it was so subtle you couldn't really see.
Fair enough. So we're doing all this stuff now based on Git commits, and we've set up a whole pipeline based on webhooks and Git. We can obviously set up the same type of system and deployment using Azure DevOps and pushing those things to ACR and doing the same type of operation if you prefer to use that in other pipelines as well.
Yeah, one of the things we built with the ACR task, because of the OS updates part, we realized that's just a primitive across all of Azure. So we want to make sure that we can support Azure DevOps, CodeFresh, Jenkins, whatever you happen to be using. So that's kind of the main goal there. All right, while that's finishing up, what else did we want to cover here? Let's come back, because that'll take a minute to run. Oh, here it is. So the thing here, just getting a quick recap, what we've done is we had the website and it was poking at these things directly. And of course, that just leaves nothing but problems. So what we wanted to do was make sure that we can support as much failure as possible. So we can run multiple web nodes, and you'd be able to see like things rotating in and out. One of the things we have there is, actually we can do this really quick because I do have that running multiple times and I have the About page. So if we go to the About page here, if we noticed where did I put the host name here? So if we rotate through, we're already starting to see our blues. And what was interesting there is you noticed that for a second there it was white and blue. That's where it was rolling it out. So that was kind of interesting there. But now I've been able to show that when not only did I change code, I guess that's not refreshing. Not only was I able to change code and get a git commit to build it, but my base image update automatically did my test and deploy as well. So, and do I have, let's see if I've got multiple instances running of the website. So
There's 2.
Was there 2?
Yeah, I'm looking at Ingress right now.
Okay. Oh, yeah. Okay, hold on. So Chrome is a really good around sticking a cache around. So I have to actually do this. This is one of the great advantages of Edge. Yeah, just go, not go to my start page.
Secure? Didn't test that, did you?
There is a way to fix it. How does it let me through?
That.
Go on to the page, yeah.
Just not recommended.
Well, I do lots of things that are not recommended. That's what makes it fun. Okay, so if we look closely here, we're going to see, that the host name is changing and it's rotating through the different nodes. So the other demo that I would also sometimes do is I'll actually manually deploy an update with the same tag and kill the node. So when the node comes back up, it's going to go pull that tag, and it's different. So you would see me flickering between red and blue, for instance. But that just, the 2 colors, I think, cause epileptic shocks.
I'm switching back to white.
Oh, you're going to go change it. Okay, so let's come back out again. All right, so we had lots of copies of the website that are rotating through. So now our website is redundant and scaling. But we wanted to make sure that we could go kill off lots of the site. So this is like the total whack-a-mole here. I've really minimized my dependencies. The quotes wasn't at all important. So we had Han Solo put some stuff in there. So that's kind of cool. I didn't need to actually submit the stuff to the backend system. I just needed to capture the user's intent. So that was really important. We didn't want to put the circuit breakers on the submission. We wanted to make sure that we put them into something that's much, much more reliable. And storage is like some stupid number of 9s reliable. Nothing's 100%. And then in the back end, we'll process. So now the user's path is protected, and we've minimized that. And then we're going to deploy this out to Kubernetes and all the way through. We use the task stuff. We talked about that. But what's also cool is I can also run this in multiple regions. I might run this in another region for redundancy. I might be East US, West US. I might be in Europe. I might be in Australia, Japan, any location. And the thing that you kind of see here is not only are the individual places redundant, we actually geo-replicate the registry, so you don't have to push the image to multiple locations. That's one of the unique features about the Azure Container Registry compared to the other clouds, is we actually have this geo-replication capability because we always want your images to be as close to your deployments as possible. So if you're running in West Europe, you don't want to pull from East US. It's slow. You want us to do the geo-replication for you. We have a webhook that will pop when the push image arrives in West Europe, and then you can do your deployments there. In this case, I had another one where I actually had localized quotes for as exciting as that was, but we'll skip that demo. But again, we can just take out just big parts of this system, and again, our users are protected. That's kind of the main message that we wanted to talk about here. So wrapping up, it's just trying to build these reliable things. There is a never-ending opportunity to continue to chase and make things reliable. And no matter how much effort you put into it, something else is going to fail. Right? We had our own issues in South Central, was it 2 weeks ago or whatever it was. It just, these major events are always a combination of things, and you can't anticipate all. You should absolutely protect for the things that you know about, sort of the things that are easy to code for, but accept that failure is going to be an option. You will sleep well at night. The modern technology, because these are not old problems, right? When we had computers under the desk, somebody unplugged it. That was norm, right? We had to understand that was going to happen. The thing around the cloud is, while you might say it's a little more unreliable because there's so many more moving pieces, the part is that's massive scale. Think about how dependent we are on technology now, right? If just 1% of transactions failed, or 1% of planes fell out of the sky, that's kind of bad. If 1% of the packages that FedEx or USPS or somebody ships got lost, that's massive. How many of the transactions are you guys processing? Can you handle that 1%? Then what's the workaround? Are you going to have to go back and process the things on the queue yourself? Or if you know things are going to fail, just have some retries in there. Go back and redo it. So containers are this great packaging format, and orchestrators are your, what did I put here? Are your nighttime managers, right? Let it do the work for you. And the biggest thing here is, while we should absolutely focus on the lift and shift and just get them into containers because that is going to be easier than managing the VMs in many ways, you really do want to start thinking, I'm not trying to justify rewriting all the old apps. If it ain't broke, don't fix it. But as you're moving forward, if you start adopting these patterns, as these things start scaling, as they start needing updates, you are going to be able to focus on the new project and not maintain the old project, because the old project will be self-maintaining. And 2.1 with .NET Core, we showed some great capabilities with the circuit breakers to get that working as well. You want to cover this one?
Yeah, so the NuGet package that we were using is poly. The actual name is poly.extensions.http. For retries, it's retry extensions. Obviously, we're using timeouts. We know that for hitting external endpoints, it's going to take some time. We cannot control the internet as far as speed is concerned. Even internally, stuff is going to time out. It'll always take longer than your users are going to wait. If you have kids, the fastest way to get their attention is to unplug the internet. So if it's not immediate, it takes too long. Circuit breakers is...
Have you had them actually disconnect other things from the router so their game would run faster?
No, I have this really cool thing that I can take over the internet. My machine is the priority. Season 6 started Fortnite today. So. It's not for me. It's like I need to do like Skype calls and stuff. So, circuit breaker is really great, as you saw here. We're going to not flood the system with requests because we're smart enough to know that we can't hit an API. So we're going to wait until something comes up, and if it's some API you're calling that you don't control, then why continue to take incoming requests and try and slow down your site if an external or third-party site is bad? So we'll just swallow those up and let that go. So message queues, obviously we're 4 nines for that. Put that in a queue, process it. For reading from that, we use the same poly type of extensions to read from that. Kubernetes secrets.
Well, the configuration is also key because one of the things we think about in containers, we don't go touch web config anymore, right? The containers are immutable, so you want to be able to extract your configuration so that you never have to rebuild the container just to be able to deploy it somewhere else. So take a look and invest in some of those spaces, and this was just an example of multiple providers that are available for configuration for like the storage queues or the databases and all the other things.
Yeah, and also for configuration, not just environment variables, there's also Azure Key Vault. For that, the Kubernetes secrets, Docker secrets, do not put that stuff in your code. Actually,
it's not really a secret at that point.
It's true. And don't check it into GitHub. I did that recently, got a lot of nasty emails about that. Luckily, it was just a demo site, not this one. And then there's the state...
Are you making fun of my tests?
Yes. And then there's state management, also for supporting the multiple nodes too. So there.
So just some links on some stuff, on some of the stuff that we demoed today. And with that, I'll come back. And so with that, please fill out the evals. We always take that feedback. We really appreciate it. We'll stick around for a bit. And thank you for hanging with us. I hope this was helpful to make your way into letting you sleep at night, not being so worried about having a mistake happen and ruin your day. Thanks.